Good afternoon. I hope you're fine and that you're doing well. For today's class, we are going to discuss something to do with inheritance. We shall be able also to go through the code to demonstrate how inheritance works in Java. So we are going to discuss inheritance at this point. And the first thing we need to understand is what is inheritance. Need to probably share a screen here so that we can go through it together. Inheritance. Right, so here we are. So inheritance is basically the ability to reuse code. It is basically the ability to reuse code or objects taking up the properties of classes or child classes taking up the properties of parent classes. And therefore, what that does is that it helps us to reuse code. And by doing that, it helps to improve code readability. It helps us to ease the time and the effort that is used in coding, and also it is memory efficient. Now, I want you to think about cars, magari. Now, when they are building cars, they normally have a prototype for the most basic things that are normally shared. There are properties that are shared when they are designing different types of cars. For instance, the engine CC may be the same with another. For instance, wheel alignment may be the same with another. As they are building cars, they normally have those properties of cars that are shared between different cars. Okay, like Toyota, these may have properties that share with other Toyota. So we have Toyotas, but there are different variations of Toyota. So when they are building, they don't build from scratch. When they are building another variation of Toyota, they will not build from scratch. They will just take up the properties of the core properties of Toyota vehicles and just copy and paste them in the next car and probably improve some things. Okay, so what they have done is that they have inherited the properties, they have inherited the features. So that is basically inheritance, right? So every kind of inheritance, basically sharing of properties, sharing of properties or characteristics. And therefore, Java, it is the ability of different objects to share the same attributes or functions of a class. Objects to share the same attributes or functions of a class. Basically, that is what inheritance is. And therefore, it helps us to ease or reduce the time taken for coding. Okay, reduce the time taken for coding so that we do not have to repeat features that replicate in different areas. So those replicated areas, the replicated attributes and functions, we basically encapsulate them in a class. All right, you remember the concept of encapsulation in programming in C++ and even object-oriented system analysis and design. We encapsulate them in a class, and then now objects can borrow or share those properties. Okay, instead of declaring, for instance, if instead of declaring, we have two students, each of them has a name and each of them has an admission number. So instead of declaring two names and two admission numbers, those are how many variables? Those are four, sorry. And they are not, that is not memory efficient. So what we do, we just declare one class a class is a dynamic variable that holds other variables. Okay, so we declare one class, so that's one variable. Inside we put in it just two variables, one name and one admission number. Then the two students are going to borrow name and borrow admission number. And then now we can probably improve, because now every student has a particular name and a particular admission number. That is basically the concept of inheritance. So you don't have to start what we call, we don't have to build from scratch. You don't have to reinvent the wheel. When we are dealing with software programming programming in general, there is that phrase we use. It's called reinventing the wheel. Reinventing the wheel is you beginning from scratch, building a system from scratch. All right. So you don't have to reinvent a wheel. You don't have to keep replicating what you already have. So inheritance helps us to do the opposite of reinventing the wheel. Is called software re-engineering or code re-engineering. So instead of reinventing the wheel, you re-engineer the code. Okay, so re-engineering is basically taking the core properties of code and just making some changes. Okay, so that is basically what inheritance is all about. Objects taking up the properties of a class so that we don't have to declare fresh the properties of every object. Okay, so it helps us to improve code readability. Code readability, why? Because it reduces the amount of code needed. Okay, and also ease of coding, and it is also very memory efficient. All right, now I want us to have a demonstration. I want us to have a demonstration in Netbeans. So let's have a demonstration, and we're going to use a program that says as follows. We're going to use a program that says as follows. Build a program in Java to enter the name and admission number of two students. It then does what? Then displays the name and admission number. Just that, use classes and objects. So when we are dealing with inheritance, we have to deal with classes and objects. Okay, remember from our definition in the previous classes, a class is basically a prototype of a program that contains data in it. A class is an encapsulation of data, and that data can be inherited. Okay, and then an object is an instance of a class that carries the properties of a class, some or all the properties of a class. Okay, so we are told here, build a program in Java to enter the name and admission number of two students. It then displays the name and admission number. Use classes and objects. Okay, let's do it. Let's go to Netbeans. Of course, enter the name and number. So build a program in Java where the programmer, so I'm going to say where the programmer enters the name. So it is the program will enter the name. Okay, so let's now do this in Netbeans. So let me stop sharing that. Let me share this. I have created I've tried to maximize this. I have created a new project. Okay, let me just go back and create. So let me come here. I'll come here, new project. Okay, Java application. Of course, that and that is normally marked by default. Next. So I'm going to call this class demo. Classes, I'm going to call it inheritance demo. Okay. Finish. Okay, so there we go. We have the workspace that has been created by default. Let me maximize that so that you can see. Then, so in this class here, this is the class that we are going to use. Okay, so in this class we are going to define some data. And what are the shared data? Two students, each of them has a name and an admission number. So we declare name and admission number. So we're going to have string name is equals to new string. Okay. So that's how we declare a string. And then int, can say int admission number, that way. Okay. Then here we are going now here inside here. So let me just delete this because it's not important. These are just comments. Okay, these are just comments. So let me remove them so that we can have more workspace. Okay. All right. I think now you can see it the way it is. Okay. Then, so I have declared inside this class called inheritance demo some two attributes that are being shared by us two students. Okay. Then inside the main method here, inside the main method, we are now going to declare the object. How do we declare the object? We declare the object using the name of the class. So you begin. The name of the class is what? Is inheritance demo. Okay. Inheritance demo. That is the name of the class. And then we're going to declare a student. The first student, let's call him student 1. All right. Is equals to new inheritance demo. That one. Okay. What I've done, I've declared an object called student1 using the name of the class. You remember still in C++, so this is the same way we're declaring objects and classes, right? So you use the name of the class to declare an object, then you follow it up with the object name. But in Java, it's different. You have the equal sign is equals to new inheritance demo. It's just the same way you declare a string. As string name is equals to new string. So inheritance demo student1 is equals to new inheritance demo. Inheritance demo, remember, it's the name of the class. Okay. Then we do the same for student2. Now what I'm going to do, I'm just going to copy and paste because of course we don't have to keep coding from scratch. Okay, we have that. Okay, then I can now here initialize the values. Just a minute. All right. So you come here and then you give the student names, okay, and admission number. So student1. So you want to give student1 the name, okay. So what do you do? You use the name of the object and you use the dot operator, and the dot operator is to access a member of a class. In other words, what property of that class does it inherit? What does it inherit? It inherits admission number and name. So I can start with name, okay. Then immediately I just type that, or student1 dot, it gives me list of the things I can do, okay. And there are two things here, data. Can you see these data items here? Admission number and name. Yeah? So these are properties of that class that we can inherit. So I'll begin with name, and then I'm going to say is equals to John Karig. And then of course you end it with the semicolon, and then you do the same for what? You do the same for admission number. So it just brings itself there. Is equals to, let's say 1, 2, 3, 4. Okay, of course semicolon. So you've defined the name and admission number for student1. So you do the same for what? Student2. All right, student2. We just change this, and then now you can have you can now print. Okay, you can now print like system.out.println. Of course, it's already here. Name of student1, plus what? Stud1 dot name. We together that way. Student1 dot name. This one. Okay, and then you can do the same for admission number. So I'm just going to edit this. So we're going just to say student1 dot what? Admission number, right? There. Okay. And then you do that now the same for what? Student2. So I'm just going to copy and paste this and then change the name of the objects. Just that. Name of student2, and of course change here so that there it can give an output that makes sense. And then now let's run this program and see what it brings. Look at that. So see what it has brought here. Name of student1, John Kariuki. Admission number of students 1, 1234. Name of student2, John Kariuki. Admission number of student 2, 1234. Now what have we not done? We have not defined the particular name and admission number for student2. So of course we should do what? We should define it. So we just come here. We give this one Peter Aurora. And then we are going to say 1578, just that. And then of course, because we need it to at least to space, we can include these spaces here. That way. Okay. Let's run it and see what it brings. Right, there we are. So name of student1. Can you see that? Name of student1, John Kariuki. Admission number of student1, 1234. Name of student2, Peter Aurora. Admission number of student2, 1578. Can you see how that works? Okay. Now, what if it was supposed to be the user entering these values? It was supposed to be the user entering these values. So I'm going to now, of course, click that, remove that. What if it was the user entering these values and then the system displays? What you do, because it's not programmer defined, so you just remove that. Then you tell the user, right? Because you can tell the user, enter details for student 1. And then of course, because now it is the user entering, we need to import which class. We need to import the scanner class. You remember the scanner class? Import java.util.scanner. You remember that? Import java.util.scanner. And of course, inside the main method, I'm going to declare an object for that scanner class, right? And this is also another concept of inheritance, because scanner class has an object. Okay, so I'm going to call it in. Okay, in for input. Scanner in is equals to new scanner. Remember how we used to define this, yeah? System dot in, right? And of course, you end it with a semicolon. That way, at least to allow us to enter the entry. So we come here, we tell the user enter details for student1. Sorry. Enter details for student1. And of course, we are going to start with what? With English. I mean, with where am I getting English? Admission number or name. Start with name. Start with name. So when you start with name, we come then here and have we say the variable is the object. So student1 dot name is equals to in dot next, that way, okay, for entering a line or a string, okay. And then you come here, you say, you can also copy and paste this, copy, paste. I'm going to delete this first so that I will test the program at some point. So this is admission number. So student one dot what? Dot ABM. So when I just bring that, it brings that in dot next int, right? Because it's a what? It was declared as an integer. Okay. So in dot next int. Okay. And then now we can say that we can now display that. We did not delete that, so we're going to use it again. So we click that, enter details for student one, name. We're going to give John, admission number 1234. Name of student one, John. Admission number of student one, 1234. Can you see how that works out? Now you do the same for student two. So I'm just going to copy and paste that there. So I'm just going to change this to student two, because that's how we are declared. Okay, see, that's how we are declared. And then of course for output, we're going to copy and paste this output here. We don't have to keep recording or typing from scratch. So student two, right? So let's run it and see how it runs. So name, we're going to add John. Can you see what has happened? I've entered the full name and it has given me, so I can actually give here next line. Let's see if that will work. Next line, and also here next line. Next line. Good. At least next line has worked the way we wanted it. So have you seen the difference between next and next line? Next helps you to enter characters without spaces. It does not allow you to have spaces as you type. But next line allows you to have spaces as you type. And then admission number, let's have 907. Okay. Then it tells us enter details for student two, name. Oh, it cannot allow us to enter the name. Name and admission number. It has not allowed us to enter the name of student two. So we just go back and see what's wrong there. So just come here. Student two dot name. Let's run it again. Okay, just Robert, admission number 5679. Enter details, name. I'm going to correct that. Anyway, the concept here that is important, I'm going to correct that as we continue. Even as you do some question, I'm going to be correcting that. So what is important here is to see the properties that have been inherited. Okay. So look at where we declared the class was already there. Okay. So inside the class, we declared some values or some attributes. They are called attributes or data members. Data members are what the class contains. Data which you can declare using types are called attributes. And then there are functions. I'm going to go into functions later. So these are attributes we declared. In other words, these are the properties that these objects are inheriting. So can you see, in the normal way of coding, we could have declared how many variables? We could have declared 4 variables, 2 names and 2 admission numbers. But here we've declared 1. Which one? The class. You know, the class is a dynamic variable, just as I had said before. So the class is a dynamic variable. We've just declared a class, and then inside it we give it attributes. Just that. So that's why we are saying memory efficient, very memory efficient, okay? That way. And we didn't have to declare a lot of variables, which was a lot of code. You know, that wasting a lot of space. So you see that. Let's look at let's look probably at another. Let's look now at another where I need to correct this first. Let me correct this. Yes, Linda, there's a difference between next and next line. Next, when you use next, like here, when you use next, it will not allow you to enter values with a space between, right? But next line, it helps you to enter values with a space between. And next just helps you to enter character values, and next line to enter string values, okay? Yeah, and precision, there is what we call character precision. So there are those characters, if you enter characters that have space, that's a character, or those are sets of characters that are deemed to have high precision. So next line is used for that case. But if you're using characters that have no space in between, then you can use next. That's the difference. Okay. So basically, oh, let me return this. There. Basically, these two properties are being inherited. Are we together? These two properties are being inherited. Okay. Name and admission number. They are being inherited by which objects? Student 1 and student 2. What if we wanted a function? I want to minimize this code so that it doesn't have to be a very long code that has a lot of details. Let me minimize this so that I can show you the most basic things about classes and objects. The other things you can keep learning, but I need to show you the most basic things, right? So for instance, I want to have a function, okay? A function. And I want to discuss with you the importance of functions. Functions are also called methods. Now, functions help us to do, they perform some certain activities. Let me share this screen. A function, or what we call a method, is basically a code that has a functionality that runs when that method or function is called, right? So inside a function, you can have data, you can have other functions, right? But mostly a method contains a function. A method contains data, attributes, okay? Now, they are also called methods or functions. Now, there are two kinds of methods. There are methods that have a return type, and there are methods that don't have a return type. Now, what is a return type? Return type is like, return type is normally invoked by the word return, the keyword return. Return type is normally used when you are performing a computation, a computation where data is being manipulated. So if you want a function that will perform some computation, a computation that data is being manipulated, for instance, adding numbers, multiplying numbers, those kinds of computations that the processor has to do, you have to have a method that has a return type. Methods that have a return type are normally declared, because you see, a method has to be declared just like a variable. Methods that have return type have to be declared using a type, a data type, like int, float, double, such kind of things, okay? But methods that do not have a return type, in other words, those are methods that do not have computations, all right, like mathematical computations. Such kind of methods, you declare them using the word static void, or you're using the two words static void. All right. Let's begin with methods that have a return type, and let's see how to create a method. And I'm going to do that by extending this question here where we have our demonstration. I'm going to extend this question, and then we are going to show, we can say, enters the admission number of 2 students. It then uses a function to compute the what? To compute the total. It enters the admission number of 2 students and their marks, in 3 subjects: English, Math, Geo. It then uses a function to compute the total marks for each student. Okay. Now let's now demonstrate the functions that normally have a return type. So we'll go to the code. Let me now share this. So inside here, I'm going to have in this class, we are going to declare how many attributes. We're going to declare English, Math, Geo, and also what? And also the admission number. That's what the question says. The question says, build a program Java where the programmer enters the admission number of 2 students. So let's assume the admission number is also int. Okay. So I've declared those variables, so attributes. Then inside that class, I'm going to declare a function for computing total. So I'm going to call it total, okay? And I'm going to use int because it is a function that has a return type, okay? Int total, that's how you do with, that's what you do with functions, all right? You see that? So int total. So the compiler now knows that there is a method or a function called total, and inside it, it is expecting a return statement. That is why you see this error here, okay? Missing return statement. Can you see what it's saying? Missing return statement. It's expecting a return statement because that's a method that must have a return statement. Why? Because it is a mathematical computation or a logical computation. So I'm going to say return. So return is used to compute. In other words, you're telling the compiler, compute this. Return English plus Math plus Geo. Okay, just that. Okay. So when you're going to come here, how many students do we have? We are having, the question says, enters the admission number, blah, 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 for 2 students. So we are going to have, we have declared already that one. I'm not going to do that. I'm going to enter the marks for each student in the given subjects. Okay, so I'm going to start with student 1 dot English. You see, English is an inherited attribute. Why is it inherited? Because it is inside the class. Okay, student 1 dot English. Let me give him 86. Student 1 dot Math. When I just type it, brings it up. 75. Yeah. Semicolon. Let me just copy and paste instead of keeping code here. Wasting a lot of time. Student 1 dot Geo. Going to have it 65, 67. Okay. And then look at this, what I'm going to do. Instead of saying student 1 dot total is equals to student 1 dot English plus student 1 dot Math plus student 1 dot Geo. That's a lot of code. And those are a lot of words. That's a lot of coding. You basically call the method. How do you call the method? Very easy. You just use the